Dear students, welcome to EPG Pathshala. Today I am going to present my module on the topic soil type. As we all know, soil is the natural resource and it is only the source which support all the life forms on the earth. It also exists on the outer surface of the land, therefore, it is also called as skin of earth. The soil of one region of world differ from the other region of the world, and the formation of soil, it takes about thousands of years to get its form. The soil also consists of organic and inorganic material deposited on the surface of the earth, which will help to support the growth of plants. The soil is also being characterized on the basis of size of particles, and it is being characterized into three categories, that is sand, silt and clay, and the combination of all these three particles forms or gives texture to the soil. The texture and the structure of the soil is very important for the growth of plants. In ancient time also there was the classification of soil, but it was only based on fertility and sterility of the soil. The fertile soil was termed as urvara and the sterile soil has been given the name of usara. But in the modern era, the classification of soil is based on either on soil texture, moisture and color. The Indian soils are also being classified on the basis of depth, shallow depth, moderate deep and deep. Different agencies are also actively participating in the classification processes like National Soil Survey 1956, the National Bureau of Soil Survey and Land Use Planning. They are classifying the soil in different categories, whereas the Indian Council of Agriculture Science has characterized the soil into 8 categories, that is alluvial soils, laterite soils, black soils, red soils, saline soils, peat or marshy soils, etc. Most soils are a combination of 3 percentages of sand, silt and clay, which gives soil its texture. There are 12 soil textural classes represented on the soil texture triangle as shown in the slide. Each texture corresponds to specific percentage of sand, silt or clay. Soil texture is highly correlated with a range of soil chemicals and physical properties. Fine textured soil with high clay contents generally have higher nutrient and water holding capacities than do coarse textured soil. Maintaining good soil structure is important for plant growth. Texture really does not change over a period of only a couple of 100 years or so, but structure can be changed rapidly, especially through management practice. Now the soil classification. A number of systems of classification has been evolved for characterizing various types of soil. Some of these have been developed specially in connection with ascertaining the suitability of soil for use in particular soil engineering projects. The more common classification systems are as geological classification, classification by structure, classification based on grain size, unified soil classification system, preliminary classification by soil types. Now there is a slide showing the map of India where the 8 different soil has been shown in the map. The soil classification in India. Geologically, Indian soils can broadly be divided into 2 main types: soils of peninsular India, soils of extra peninsular India. The soil of peninsular India are those which have been formed by the decomposition of rocks in EC2, that is directly from the underlying rocks. They are transported and redeposited to a limited extent and is known as sedentary soils. On the other hand, the soils of extra peninsular are formed due to the depositional work of rivers and wind. They are mainly found in the river valleys and deltas. They are very deep and constitute some of the most fertile tracts of the country. They are often referred to as transported or adjournal soils. The Indian Council of Agriculture Research set up All India Soil Survey Committee in 1953, which divided the Indian soil into 8 major groups. They are alluvial soil, black soil, red soil, Literite soil, mountain soil, desert soil, saline and alkaline soil, peaty and marshy soil. This is a very logical classification of Indian soil and has gained wide acceptance. Now, a brief account of all these 8 soils. First, we will take alluvial soil. Alluvial soils are by far the largest and the most important soil group of India, covering about 15 lakh square kilometer or about 45.6% of the total land area of the country. These soils contribute the largest share of our agricultural wealth and support the bulk of India's population. Most of the alluvial soils are derived from the sediments deposited by rivers, as in the Indo-Gangetic plains, although some alluvial soils in the coastal areas have been formed by sea waves. Thus, the parent material of these soil is all of transported origin. The streams bring with them the products of weathering of rocks from mountains and deposited them in the low-lying areas. The alluvial soils are yet immature and have weak profiles. They differ in consistency from drift sand to rich looms and from silts to stiff clays. A few occasional conker beds are also present. However, pebbly, stony or gravelly soils are rare in this group. The chemical composition of alluvial soils make this group of soil as one of the most fertile in the world. The proportion of nitrogen is generally low, but potash, phosphoric acid and alkalis are adequate, while iron oxide, lime vary within a wide range. The porosity and texture provide a good drainage and other condition favorable for bumper crops. Next is black soils. The black soils are also called rigor and black cotton soil because cotton is the most important crop grown on these soils. Several theories have been put forward regarding the origin of this group of soil, but most pedologists believe that these soils have been formed due to the solidification of lava spread over large area during the volcanic activity in the Deccan Plateau thousands of years ago. Most of the black soils are derived from 2 types of rocks, the Deccan and the Raj Mahal trap and ferruginous genesis and schist occurring in Tamil Nadu. The former are sufficiently deep while the latter are generally shallow. Crabs hold that the rigor is generally a mature soil which has been produced by relief and climate rather than by particular type of rock. According to him, this soil occur where annual rainfall is between 50 to 80 centimeter and the number of rainy days ranges from 30 to 50 days. The occurrence of this soil in the West Deccan, where the rainfall is about 100 centimeter and the number of rainy days more than 50, is considered by him to be an exception. In some part of Gujarat and Tamil Nadu, the origin of black cotton soil is ascribed to old lagoons in which the river deposited the material brought down from the interior of peninsula covered with lava. The black soil is very retentive of moisture. It swells greatly and becomes sticky when wet in rainy seasons. Under such condition, it is almost impossible to work on such soil because the plow gets stuck in the mud. However, in the hot dry season, the moisture evaporates, the soil shrinks and broad and deep cracks are visible, often 10 to 15 centimeter wide and up to a meter deep. This permits oxygenation of the soil to sufficient depth and the soil has extraordinary fertility. As a general rule, black soil of upland are of low fertility, but they are darker, deeper and richer in the valley. Because they are high fertility and retentively of moisture, the black soils are widely used for producing several important crops. Some of the major crops grown on the black soil are cotton, wheat, jawar, castor, sunflower, millet, whereas rice and sugarcane are equally important where irrigation facilities are available. Large variety of vegetables and fruits are also successfully grown on black soil. Next is red soil. The comprehensive term designates the largest soil group of India, comprising several minor types. Most of the red soil have come into existence due to weathering of ancient crystalline and metamorphic rocks. The main parent rocks are acid granites and gneisses, quartzitic and felspathic. The color of these soil is generally red, often grading into brown, chocolate, yellow, grey or even black color. The red color is due more to the wide diffusion rather than to high percentage of iron content. The red soils occupy a vast area of about 3.5 lakh square kilometer, which is about 10.6% of the total geographical area of country. The texture of these soil varies from sand to clay, the majority being looms. On the upland, the red soil are thin, poor and gravelly, sandy or stony and porous, but in the lower areas they are rich, deep, dark and fertile. The red soils responds well to the proper use of fertilizer and irrigation and give excellent yield of cotton, wheat, rice, pulses, millet, tobacco, oilseeds, potatoes and fruits, etc. Next is laterite soils. The word laterite was first applied by Buchanan in 1810 to a clay rock hardening on exposure observed in Malabar, but many authors agree with Famore's restriction of this term to soil formed as 290 to 100% of iron, aluminium, titanium and manganese oxides. Almost all 5 Hoppen soils are very poor in lime and magnesia and deficient in nitrogen. Sometimes the phosphate content may be high, probably present in the form of iron phosphate, but potash is deficient. At some places there may be higher content of humus. Laterite and lateritic soils are widely spread in India and cover an area of 2.48 lakh square kilometer. Next soil, forest or mountain soil. These soils are mainly found on the hill slopes covered by forest. These soils occupy about 2.85 lakh square kilometers, which is about 8.67% of the total land of India. The formation of these soil is mainly governed by the characteristic deposition of organic matter derived from forest growth. These soils are heterogeneous in nature and their character changes with parent rocks, ground configurations and climate. Consequently, they differ greatly even if they occur in close proximity to one another. In the Himalayan region, such soils are mainly found in valley basins, depressions and less steeply inclined slope. Next is desert soil. A large part of arid and semi-arid regions in Rajasthan and adjoining areas of Punjab and Haryana lying between the Indus and the Aravallis, covering an area of 1.42 lakh square kilometer and receiving less than 50 centimeter of annual rainfall, is affected by desert condition. The run of Kutch in Gujarat is an extension of this desert. Some of these soils contain high percentage of soluble salts, are alkaline with varying degree of calcium carbonate and are poor in organic matter. Our large part the calcium carbonate content increases downward and in certain areas the subsoil has 10 times calcium as compared to the topsoil. The phosphate content of this soil is as high as in normal alluvial soils. Nitrogen is originally low, but its deficiency is made up to some extent by the availability of nitrogen in the form of nitrates. Thus, the presence of phosphate and nitrates make them fertile soil wherever moisture is available. There is therefore great possibility of reclaiming these soils if proper irrigation facilities are available. Next, alkaline and saline soils. These are found in Andhra Pradesh and Karnataka, in the drier part of Bihar, Uttar Pradesh, Haryana, Punjab, Rajasthan and Maharashtra. These are salt impregnated or alkaline soil occupying 68,000 square kilometer of area. These soils are liable to saline and alkaline efflorescences and are known by different names such as ray, six-hopan, usar, thar, rakar, color, etc. There are many undecomposed rock and mineral fragments which on withering liberate sodium, magnesium and calcium salts and sulfurous acid. Some of the salt are transported in solution by the rivers which percolates in the subsoil of the plain. In the canal irrigated areas and in areas of high subsoil water table, the injurious salt are transferred from below to the topsoil by capillary action as a result of evaporation in dry season. The accumulation of these salt make the soil infertile and render it unfit for agriculture. Next is peaty and marshy soil. These kind of soil originated in humid region as a result of accumulation of large amount of organic matter in the soil. These soils contain considerable amount of soluble salt and 10 to 40% of organic matter. Soils belonging to this group are found in Kottayam and Alappuzha district of Kerala, where it is called Kari. Marshy soil with the high proportion of vegetable matter also occur in the coastal area of Orissa and Tamil Nadu, Sundarbans of West Bengal, in Bihar and Almora district of Uttaranchal. The peaty soils are black, heavy and highly acidic. They are deficient in potash and phosphate. Most of the peaty soils are under water during the rainy seasons, but as soon as rain ceases, they are put under paddy cultivation. From the lecture, now it is well cleared and can be concluded that the soil classification process is not a new process, but it is there since ancient time. Only the difference is lying on the changes in the criteria of classification of soil. This is the process which will provide the soil formation information and its behavior information, which will be useful in agricultural system. Now, due to the degradation of our this very natural resource by the different activities like deforestation, construction and other processes, it has been put under pressure or it has been degraded. But with this soil type and classification, this natural resource can be reclaimed, because during the soil classification process, its formation and its productivity have been explained. So, applying all this knowledge, the soil can be reclaimed. Further, it can be a very useful tool for the engineers and community planners, because if we take the example for engineers with the help of soil classification, they may know the potential behavior of the soil and its limits, and with this knowledge they can plan their project and their project will become economically beneficial. Projects like your buildings construction or your bridge constructions. Whereas, if we take the example of community planners, with this the knowledge provided by the classification process, the community planners can understand the type and the structure of the soil and can plan better recreational areas, green belts and gardens for the community. Thanks.